we are going to kind of see if you can correctly fill these words in as we're going through. So if you think you know the answer, you could just say it. Okay. Dilation means changing the size of an object without changing its shape. Very good. And by the way, if you are a highlighter person, I am going to use 2 different colored highlighters today. You do not have to get them out, but some of you I know like to use them when I'm using them, so feel free to get those, okay? The next 3 blanks are the most difficult for people. A scale factor is the close ratio. Okay, ratio of the think about our pictures and what we call the 2 figures. Image. The scale factor is the ratio of the image to the pre-image. Now, because we're going to use that a lot today, I'm going to have you write that off to the side right here. We do the image over the pre-image. Okay? That is important today. Image over pre-image when we are doing our ratio. So now we've been talking about, this is kind of review, congruent and similar. So congruent figures have the same shape and the same size. Very good. Same shape and the same size. To be congruent, the figure must be transformed by, raise your hand if you can tell me one of the transformations. Translation. Lily. Rotation. And that means last one, Emma. Reflection. Very good. So congruent, same shape, same size. That's translation, sliding, rotation, turning, reflection, flipping. Okay. Similar figures have the same shape, but can be different size. Now, why did I say can be and doesn't have to be different size? Marley?
Yeah, because like they're the same shape.
Not quite. This is what was throwing you guys off on the homework, that multiple choice homework the other day. Jackson?
You can divide it by 1 and just say the exact same.
Yes, if our scale factor is a 1, that means we multiplied by 1. Anytime you multiply by 1, that's multiplicative identity, okay? They stay the exact same. So that in that case, we would still be having a dilation because we have our scale factor. It's just technically the shape and the size stay the same then, okay? So to be similar, the figure must be a, anyone? Dilation. Very good. Very good. Okay. So it says, determine if triangle HGI is similar to triangle EDF by using transformations. The way this is worded, it's saying that this is technically the one we are starting with. I will tell you today, the book does a very bad job of telling you which one to start with. So I always tell you today that your left one is always going to be your pre-image, and your right one is going to be your image. Now, is that always going to hold true? No, but I have always given you the ones today that it does work out that way. Okay? Or sometimes, like I said, the book doesn't actually tell you which way it wants you to go. It doesn't tell you map this onto this. So because of that, we always do the left is the pre-image and the right is the image, because we kind of just take it as you're reading like across, like you're reading a sentence. Okay? So first part should be really easy. Are these two congruent? Is the pre-image congruent to the image? No, why not? Yeah, they're different size. So no, they are different sizes. Okay. Then, to test if they are similar, well, look at them. Do you think they're similar? Okay. Before that was good enough to look at it and say, yeah, I think it's exactly the same shape, so we're going to call it similar. Now it is not good enough, okay? Now we want to actually prove that there is a scale factor that's being used, so they are the exact same shape. So, this is where I'm using my highlighters to find our corresponding sides. DE corresponds with, anyone? GH. Very good. Way to put it in the correct order even. Okay. So when we do that, let's look at it. DE is what length? You can just count them. 4. Very good. GH is what length? 8. Okay, if you don't highlight, it's fine, but still label them so you know where your numbers are coming from. Okay. So remember, we said to test for the ratio, the scale factor, we are always going to do image over pre-image. So I'm going to write that down just to remind us. Image over pre-image. Image over pre-image, okay. When we do our image over pre-image, that means we're going to be doing what number, Sullivan, over what number?
8 over 4.
Great. 8 over 4, our image over our pre-image. What is 8 divided by 4, guys? 2. Okay. Now we're going to do another side. It's not enough just to test one side, okay? So DF is with GI. Good job on the order. DF, what length is that one? 3. GI, what length is that one? 6. Good. So Carter, when I go to write out the ratio, I'm going to do what number over what number?
You're going to do 6 over 3.
Good. Image over pre-image. So 6 divided by 3 is anyone? 2. Great. Now, normally we want to check all of the sides, specifically when it is a right triangle. You technically do not have to check all of the sides because of the fact that in a right triangle, since we know these angles are the same, if then this pair of sides have the same scale factor as this pair of sides, then we technically know this one also has to be the same because there's that right angle in between. Does anybody remember the Pythagorean triples? Like, do you remember if this is a 3, 4, this has to be a 5. It's a 3, 4, 5 triangle. Okay, very good. 3, 4, 5 triangle. That's a Pythagorean triple. If you didn't know, the other thing that we could do is we could do the Pythagorean theorem. It's a right triangle. So we could say, okay, 6 squared, because that's one of our legs, so 6 squared, plus 8 squared is our other leg, and that gets us 100. So then what would we have to do with that 100? Not divide. Square root. Very good. And when we take the square root of 100, we get 10. So we know this would be 10. You cannot actually count a diagonal line. Okay, so don't try counting that across and saying, oh, I counted, it's 10. You can't count that. Okay, but in this case, you would have actually noticed that, okay, our 10 over 5 actually is 2 as well. Okay, so because we got all of the same number, are these similar? Yes. Yes, because they have the same, what? Shape. They are just a different size. Very good. Same shape, different size. Okay. So if they are similar, we can say we use these specific transformations to go from here to here, to go from the image to the, or I'm sorry, the pre-image to the image. So what transformations were used in this? What did we do? Take a second to think about it. I'll give you like 15 seconds, then I'll take an answer. What did we do to go from the pre-image to the image? Ziva, what do you think? Good, okay? Now, some people like to be very specific with their translations. The problem with this translation and the dilation is when it is not on a coordinate plane with the 4 quadrants, and we don't know what we are dilating about then, it's kind of tricky looking at these. So for the translation part of it, what I tend to do to begin with is I pick one point and I pick the corresponding point in the other one and I move that first. So how did I go from D to G? I translate, how? How did I move? Anybody? Okay, down 2. I went down 2 and then 5 to the right. The reason the translation is tricky is if I would have picked a different point to go off of, we would have went a different way or a different amount of spaces. Like if I went to F to I, that would have been different. Okay, I always tend to go with like the bottom left corner because that tends to be the most accurate. But truthfully, guys, when I do this, I tend to just put translate and then the dilation with the scale factor. If you are somebody that likes to be specific, that's the way I would suggest to do it. But if you even just put translation, I'm fine with that. Okay, so translate and dilate with a scale factor of, and don't think too hard on this, we already did it. Justin, what was the scale factor we found? 2. They had a scale factor of 2. So again, honestly, on my answer key, I have translate and dilate with a scale factor of 2. But most classes today have really wanted to tell me how to translate. So if you want to be specific, that's all right. Okay? Any questions on that first one? Okay, next one, same type of thing. Determine if rectangle W, X, Y, Z is similar to triangle VWTU by using transformations. And again, the way they worded it is they want to know if this is similar to this. That means this was the starting point. But again, today we are always working as our pre-image is our left one, which is exactly what they told us. That was our starting point. And this one is the image. The one on the right is our image. Okay? So because these are rectangles, when I look at this, TU here is also going to be the same length as what other side of that rectangle? TU is the same as, no, the same as what part of that particular rectangle? WB, right? Those are the same. So it really doesn't matter which one you look at. What are the corresponding parts to those two of the other rectangle? YZ and XW. Very good. Okay. The reason I had you do both is because earlier we just did one, and then they're like, but how do I know if it's this one or this one? Well, at the moment we can't quite tell because if you turned it this way or if you turned it this way, it could be different. So that's why we're just going to take both of them at the same time. Okay. TU is what length? I heard somebody say it. 3. Very good. And YZ is 4. Okay. Oh, we forgot to answer, are they congruent, aren't they? I just jumped right to similar. Okay, so are they congruent? No. They're different sizes. We can already tell they're different sizes. We have one that's 3, one that's 4. They can't be the same. Okay. Similar now, when we go to do the similar part, remember we always do our image over our pre-image. So what is my image number, Austin?
Image number is
We've only named 2 numbers so far. Which one is for the image?
4.
4. So we're doing 4 over, what was for the pre-image, Austin? 3. Very good. Guys, in your calculator, can you please do 4 divided by 3? Reese, what did you get? 1.3 repeating. Guys, can I write 1.3? No, that is not the same. Not the same. You have to write the exact number for me. Okay? Now we're going to go with the other sides. I know that since it's a rectangle, T, W, and UV are going to be equal to each other because that's just the way rectangles work. The opposites are the same length and they're parallel. So ZW and YX are going to be the paired up ones on the other rectangle. Let's do UV. What is the length of UV? Anyone? 5. What about the length of ZW? 7. Katie Lynn, we're going to do what number over what number for my ratio? 7 over 5. Very good. Guys, if you do 7 divided by 5, you get 1.4. Are those the same numbers? So what does that mean?
It is not the same.
They are not similar. Very good. So we're going to write no, and it's that they are not the same shape. They are not the same shape. Okay? So, who can tell me what transformations are used to get from the pre-image to the image? Jackson. It is. Very good. What do you mean there are none?
Because since it's not the same shape or the same size, you can't find a place that won't be a good fit.
Yeah, fantastic. Guys, remember up here we said congruent means same shape, same size. Similar means same shape, different size. They both have to have the same shape. If we do not have the same shape, we cannot turn it, reflect it, so translate, rotate, reflect, dilate. We can't do those things to get one to be the other if they're not the same shape. And I always have somebody that's like, but Mrs. Lumley, they're both rectangles. They are the same shape. They can be the exact same shape as in they have the same number of sides, the same sides are parallel and congruent, but not actually be the same shape of that type. Okay? What I mean by that is, remember yesterday we said to be similar, this would be like on your computer where we have the picture and we click the corner and we drag, because that makes all of them bigger proportionally. So this got bigger, just not bigger proportionally. So they are not similar. They are not the same exact shape. They're not the exact same type of rectangle. Okay? So for this part, what transformations we are going to write? There are no transformations that can be used. There are no transformations that can be used since it is not similar or congruent. There are no transformations that can be used since it is not similar or congruent. Okay? Once you have that one done, I want you to go ahead and start trying Got It A. Got It A is just like the last two that we've done. So go ahead and try that. Now's a great time to be asking questions if you have them.